Okay, so week 11, all extra credit. And I already went over all these extra credits in my previous video and lecture notes from Monday. So you decide what you want from me today. If you want me to, I can go over and do it again. Or I can answer any questions about any assignments in particular. You're the boss, you tell me.
Can we order pizza?
Can we order pizza? Yeah, as soon as I'm done. There might be some pizza in the pizza club, so.
What do you mean money?
I gave them money. I don't know if they're gonna get it as usual. You know, I keep bribing people, but it doesn't always work.
Or you get different people to bring food?
No, I gave one person. I gave the treasurer money to get pizza, and she did it one time, but
She hasn't done it.
she hasn't done it since then. So, yeah.
Wait, what's she doing with your money then?
I don't know. Maybe you should make you the treasurer. You should. Yeah, an official title. You could be doing it.
I mean, sure, if you guys want me to bring food.
Yeah, you'll be reimbursed
Okay.
if you like to. That would be wonderful.
Okay. What would I have to bring? Am I supposed to bring pizza?
Would be nice, yeah.
Just pizza, that's it?
Sure, something vegan if you like.
I'm just gonna bring wheatgrass.
There you go.
That's all.
Bring us some juice.
There you guys go. You're welcome.
Eat some grass. Just get some roots from the yard and bring them over.
Bring some organic tortillas.
Some organic carrots.
Organic tortillas. Yeah,
Do
that's
they
all you need.
still have the house
Yeah,
with fire?
Okay, so why don't we do this and then we'll talk about food? How's that?
Wait, what?
What would you like me to do? Would you like me to go over all these? By the way, I did go over all these in my lecture for Monday. It's in the notes. It's in the video. If you like to, I can go over it again. I can go over any assignments that you found difficult or you want me to go over or whatever you like.
I have questions on previous assignments.
Okay, which assignment?
Give 27.
Give me something. 27.
That's from week 5.
Okay, 27. P27. Smallest, largest sum average with random numbers. Okay.
Okay.
All right.
Well, first of all, I'm confused. Okay. Is it supposed to? Am I supposed to say give me 3 random numbers?
Mm-mm.
Or am I supposed to input the numbers?
You don't input anything. You don't ask the user anything. You don't input anything. You make the random numbers, and let's just do it. Why don't I do this, and then I'll do one that's similar to this with arrays, so that you get some practice. Okay, so let's fire up C Lion, right? And again, all the hints for a lot of assignments are in the lecture notes and video for Monday. So look at that if you wanna know how to do those, unless I cover it today. Okay, so first of all, how do we make a random number? Okay, to make a random number, you have to do this line right here, which is the I seed is equal to time null, which is basically we're getting the system time from the computer, and then we're going to feed that system time into the srand function. And then once we've done that, then we can start making random numbers. Okay, so in this particular assignment here, it says write a program that generates x random integers num. And it says that num is a random number between 20 to 50, and x is a random number between 10 to 15. Okay, so why don't I change this thing to num, and you tell me how to make a random number from 20 to 50. How do I do that?
It would be 20 plus random parentheses percentage. Where did I put it? 31.
Awesome. Okay, so that's how you make a random number. Random num between 20 to 50, right? Okay, so that's one. And then the other one is going to be x, which is a random number between 10 to 15. So let's make another one. Int x is equal to what?
10 plus rand.
10 plus rand modulus what?
6.
6. Okay, good. Okay, so this is a random num between 10 to 15. Okay, so now that we have figured this out, what we're going to do is we're going to create x random numbers. Okay, so we're going to create x random numbers num. Okay, so I'm just going to make a loop. Okay, my loop is going to be for int I is equal to 0, I is less than x, I plus plus. Okay, and then in here I can do something like cout. So,
Are you in class?
yeah.
Okay. I'll come back later.
Okay, so I'm gonna say making x random numbers, like that. Okay, and then in here, what I'm going to do is, so how many times is the loop going to happen? How many times is this loop going to happen?
However many times you put like x.
X. So it will happen as many times as x, right? Okay. So in this loop is actually where I'm going to be making this random number. Okay, so this thing that I just did here, I can copy it and I'm going to paste it right in there. Okay, so this is make a new random number every time. Okay, so every time we go through the loop, which is going to be anywhere between 10 to 15 times, right? So since that's what's the value of x, right? Then every time we go through the loop, we're going to make a new random number between 20 to 50. So far, so good? So why don't I show you each of these random numbers? Cout, num, and then maybe a little space after it. Okay, and then after it's done with all that good stuff, I'm going to do cout and del. Okay, so let's test this thing, see if it works. So I'm going to run it, and making 13 random numbers, and these are my 13 random numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so 13 random numbers, and each of these random numbers is between 20 to 50. Okay, so if I run this again, I'm going to make a different number of random numbers. All right, so this time I did it. It's 15 random numbers. If I run it again, this time it's 12 random numbers. Right, so every time I run it, it makes a different number of random numbers, and each of the random numbers is different, or it's random. Yes? Okay, so what else are we supposed to do? We're supposed to find sum of the numbers, right? Let's start with the sum. So I do int sum is equal to 0, and then I'm going to add every one of these random numbers to the sum. Sum is equal to sum plus these random numbers. I can also do sum plus equals num, right? Either way works. So far, so good? Okay, so this is the sum of the random numbers. If I wanted to do the average, then I do cout average. So let's just do sum equals sum and del. Cout average equals, what's the average? Sum divided by what?
X.
Awesome, x. Okay, so we found the sum, we found the average, so let's see what else. So smallest, largest, sum, and average. So we figure out the average and the sum. Let's do the smallest. So what I'm going to do is I'm going to make an int smallest, right? I'm not going to make it equal to anything initially. So what I'm going to do is I'm going to make, so here I'm going to say make smallest equal to the first random number. Okay? And the first random number, how do I know it's the first random number?
You set it equal to 0.
No.
Okay,
If I make smallest, okay, so let's put it this way. If I have made smallest equal to 0 initially, right? Is any of these numbers going to be smaller than that?
no.
No, because they're all they're all between 20 and 50, so smallest is going to stay at 0. Okay, so there's a couple ways to do this. Any ideas?
You set it to 20 then?
if I set smallest equal to 20, then none of these numbers would be smaller than 20 again, right? So since the numbers are between 20 to 50, none of these other numbers that I'm going to make is ever going to be smaller than 20, since the smallest is 20 already. So what, in this particular case, notice in here, I don't have any 20s, right? So what's the smallest? Still 20. But we never even generated a 20. So what else you have? What other ideas? It's getting closer and getting warmer.
Yeah, I got that.
You got nothing?
That was my
Okay. So instead of making smallest equal to 20, one way to solve this is if we say, what if we make smallest bigger than any of the numbers that we could make? So the numbers here that we can possibly make are going to be between 20 and 50, right? So if I make smallest equal to 51, right, that means that any of these numbers will be smaller than smallest. Does that make sense?
Yeah.
So then I say, all right, well, if that's the case, then if any of these numbers, right? So the first thing I did is make smallest bigger than all numbers initially, right? And then compare smallest to all numbers, right? So if any number is less than my smallest, right? If any number is smaller, then I just say smallest is equal to that number. Smallest is equal to that number. That is your new smallest. Okay? So let's look at this particular case, right? So if we make 12 random numbers here, right? Smallest is initially 51, right? So we look at the first number. Is 28 less than smallest? Yes, right? So at that point, smallest is now equal to 28. Then we go to the next one. Is 26 less than smallest? Yes. So now smallest is 26. And then we go to 38. Is 38 less than smallest? No, because smallest is 26. We went through. So remember, initially smallest is equal to 51. We look at the first number. Is 28 less than 51? Yes, it is. So now smallest is equal to 28. Then we look at the second number. Is 26 less than the previous one that we found, which is the 28? Yes, it is. So now smallest is 26. Then we go to the next one. Is 38 less than 26? No. Is 36 less than 26? No. Is 39 less than 26? Is 43? Is 25? Yes. So now smallest is equal to 25. We go to the next one. Is 29 less than 25? No. Is 38 less than 25? Is 24 less than 25? So now smallest is equal to 24. And that's it. There's no other numbers that are smaller, so I found the smallest. Does that make sense?
Yes.
So C out, smallest equals smallest. All right, and L. Now let's see if we get it. We run this thing again, and yeah, there's a 24, so that's the smallest of all these numbers. We can run it again. All right, now it's 21 is the smallest of all these numbers. Okay, make sense? Okay, so how do you think we're going to make the largest then? So I'm going to go in there and you help me. Largest is equal to what initially?
19. Would it be the
Okay,
opposite?
sure, 19, yep, exactly, okay. And then I'm going to go in there and now I'm going to compare if any number is what?
Is bigger than
Bigger than largest, right? Then largest is equal to that number. Right? And that's it. Semicolon and show the largest. Okay, and let's check it. Run this thing. There we go. We have a bunch of numbers. Smallest is 23, largest is 49. Okay, it works here. Let's try it again maybe. All right. This time we have a 50 as the largest, smallest is 21. Is that right? Yeah, I have a 50, I have a 21, there's nothing smaller. So it works. Okay? Make sense? All right, what else? That's the whole problem.
Not yet there.
What else you got?
You know, that up or
Huh?
a good example on the
Yeah, I'll upload the video and the notes.
place.
Yeah, of course. Are we good with this? Do you have any other questions? Going once, going twice. No? Not yet? All right. Let me show you some of the ones that some people had questions on. Okay, so let's go and look at there's a problem where you have to deal with arrays. And I don't remember which one it was, so let me go jump to the array section just to revisit arrays. Arrays and pointers. Okay, so there's an assignment in there, number 54, which kind of, you know, deals with random numbers again, right? So here's how it goes. You're supposed to make an array of random elements, okay? And the array, the number of elements in the array is going to be between 20 to 30, okay? Still with me?
Okay, sorry.
So what we're gonna do is we're supposed to make an array of x random elements, right? And x is a random number between 20 to 30, and then n is a random number between 100 to 200 this time. And it's saying must use your random min max function to return the value into each n. Okay. So now what we're gonna do is let's put this random number business that we created, right? Meaning this stuff here, let's put that in the function. So I'm going to make a function int rand int, and that function is going to take an int min, int max. Can you see that, Rigo?
Yes.
Okay. And then I'm going to grab this thing here, and I'm going to make a random number, return min plus rand modulus max minus min plus 1, right? That's how you make a random number, right? So if you're trying to make a random number between 10 to 20, 10 is your min, max is 20, 20 minus 10 is 10, plus 1 is 11, so 10 plus rand modulus 11 is a random number between 10 to 20, right? That makes sense? You don't have to all answer at once.
Yeah, that makes sense.
Yes.
Okay, so now that we made this function, we're going to use this function to make an array. All right, and you remember why the programmer left his job, right?
No, why?
Because he didn't get arrays.
Oh.
So let's do some arrays. Okay, so first of all, we're going to make an array of x random elements. So remember, if I want to make an array of 10 things, I'll say int array 1 10, right? But I don't know if it's going to be 10. I want this thing to be anywhere between 20 to 30. I'm going to store that value into x. So this is going to be x elements, and the x is going to come from my rand int function, and that's going to be between 20 to 30 long. Okay? So that's how big my array is going to be, anywhere between 20 to 30. I don't know for sure. Okay? So in here, I'm going to say cout making an array of x elements. Okay? So far so good? Still with me? Okay. So I'm going to make an array anywhere between 20 and 30 elements. So now I have to fill this array with actual values. Okay? So I'm going to go in there and I'm going to do, all right, let's make a loop for int I is equal to 0, I is less than x, just like before, I plus plus, right? And in here, I'm going to say array 1I is equal to, and then what the values for this array are supposed to be, they're supposed to be random numbers between 100 to 200, right? So I'm going to fill this array with random numbers from 100 to 200 each. That right there should do it. Okay? So this is your P54 hint. P54 hint. All right. I don't remember. What was the first one, Heidi? What was the number? What was this? 27?
27, yeah.
P27 hint. And by hint, I mean solution. So, okay. So this is my array, right? I'm hopefully filling up this array with values. Now let's go and show the array. All right. So this is fill the array with values. Okay. Now we're gonna do show the array. All right. I'm just gonna recycle this loop right here. So throw it right in there. I'm gonna do a cout, and I'm gonna say array1 square bracket. And then we're going to throw the I in there. And then I'm going to do another square bracket equals array1I. End L. Okay? So let's see what it looks like. So I grab this thing, I run it, and it looks like this. Alright? So it says making an array of 29 elements, and this is the array of all these different elements. Okay? Make sense? Alright, so now the next step is we want to make a second array. If you look at the assignment, so let's say this is your first array here, right? So what you want to do is you want to make a second array, but this time what we're going to do is the first element of this one is going to be the last element of the other one, doubled. So this one is, if the last one here was 162, the first one here is 324. If the second to last was 135, the second one here is going to be 270, right? And the last element here, the 21 or whatever, the 22, is 334, which is actually twice the first element here. Okay? So how are we going to do this? Any ideas? So now what I'm trying to do is make another array equal to the first array, but doubled and in reverse order. So give me some ideas. What do you have, Rigo? I know something's cooking in that big brain of yours. Nothing? How about you, Heidi? What do you have?
What do you?
Come on, give me something.
Well, would you put it like in the conditions to double it?
Which condition?
Like before the for int, would you put, instead of putting that it starts with 0, Oh no, because it's still starting with 0, but it's never mind.
You're kind of going towards the solution. So I think what you meant to say is start it in reverse maybe. So get this loop and start it going in reverse. So let's say let's do this. So this is my the array in ascending order, or in regular order, right? So let's start with this. I want to show the above array, but in reverse. Okay, and let's do a little separator in there so we can tell which one's what. So how am I going to show this? Basically, I want to do this thing, but in reverse. So I'm just going to copy this whole thing here, and you help me fix the loop so that it goes in reverse. How do I do that? Where does this start first? And let me give you a clue. So let's say here x. Let's suppose x is equal to 20. Yes? So that means that when I was showing the x here, right, x is going to, so I values here are going to be 0, 1, 2, 3, and then what's the last one? What will be the last one? 19, excellent, Heidi. So 19, right? So that's the last one. So 19, but what's 19? 19 is equal to x minus what? This is my x, right? So 19 is x minus 1. So where am I going to start this initially at? In terms of x? X minus 1. Okay? All right. And then so what I want to do this is, what I wanted to do is I wanted to go, nah, if x is 9, if the last one was 19, or if we're talking about of x or 20 things, right? So this thing is going to start at 19, then it's going to go 18, then it's going to go 17, and then so on and so on. And the last one, where would it stop? 0. Excellent. Okay, so how am I going to make this loop stop at 0? First of all, this is going to go backwards, so how am I going to tell it to go backwards? Plus changes to what? Minus, right? Okay, and this here, this middle piece, how am I going to change this? So I'm telling it start at 19, go on until you reach a 0. So how do I change this piece? Greater than x. Okay, if I have it as greater than x, then it will stop at 1 before the x. So it will actually stop at 1. So if I wanted to go to 0, how do I change it to?
Put 0.
Greater than. So yeah, it's not x. Sorry, you're right. It actually should be. If I had a 0, then it will stop at 1. That's what I meant to say. Okay. So, but if I don't want it to stop at 1, I want it to go to 0. What do I need to change the 0 to? Or what do I need to change here? Take your time.
If you want to stop at 0, you said?
Yeah. So before, if it's like this, it goes to 1. But what I wanted to do, so the way you have helped me configure this loop, it will start at 19 and will go to 1. But I wanted to go to 0. So how do I change this loop?
Greater than or equal to 0?
There you go. All right. I can do greater than or equal to 0. I can also do greater than minus 1. Right? Either way works. Okay, let's go greater than or equal to 0. I like that. Okay. All right. So now if I go and I run this loop again, let's have a look at this loop in reverse. I mean this array in reverse. Am I getting the same things? Array 21 is here, it's first. Array 20 is there. So it looks good, right? You approve?
Yes.
Okay. All right. So now what I'm going to do is I'm going to make another array. All right. I'm going to go in there. I'm going to make another array. In fact, I'm going to make it right here. I'm going to make both of these arrays. I'm going to declare the array. All right. Declare the array 1. So I'm going to declare array 2 the same way. All right. Declare the array 2. Yeah. So now, how am I going to, instead of just showing this array, right? I'm showing the array here. Throw in some curly brackets for you. All right? So instead of showing this array here like I did, I want to make the other array, array 2x, equal to that values that I'm showing you. Let's start with that. And keep in mind, I want it to be in regular order. So in other words, if this is my array 1, right? Suppose, let me give you an example. So if I had this situation here, I had these here, right? Then array 2, 0 is equal to this one. Array 2, 1 is equal to this one. Array 2, 2 is equal to this one. Right? So in other words, this here, the value that you're seeing for this here, this piece, this is my I, right? So this is the values of I here. I equals this. Okay? So how am I going to create this here? Let's call this J. J. Okay? Any ideas? All right.
Or do you do like the
Point what?
value thing where you make them equal each other?
What do you mean?
Like how before the memory address.
All the pointers?
Yeah.
No, you don't need to do pointers. So let's just think about this. So the value of J is going to start at 0, right? You agree?
Yeah.
The first one is always going to be 0, right? So I'm going to go in there. I'm going to say, okay, well, int J equals 0, right? So then I'm going to go in there. I'm going to say, okay, well, array 2J equals array 1I, right? Does that make sense?
Yeah.
Okay, but the value of J has to increase by 1 every time. So how am I going to do that?
J plus plus.
J++. I can put the J++ here, or I can actually put the J++ right in there. Oh, did that blow your mind? Okay? Does that make sense?
Yes.
So why don't I'll just put the J in there and I'll put J++ underneath it. Yes? Okay, so now basically this loop is going to go through the entire other array. And this first array here starts at 0, and then we're packing it with all the values of this other array. But I also mentioned in the assignment that I want the values to be doubled. Right? So how am I going to double the values of the first array? No, I++. So if this array, so for example, let's say this, we're dealing with this situation, right? Array 0 is equal to array 121, which is equal to 125. How am I going to make array 20 equal to this value but doubled?
Would it be I times 2 since you can do plus plus?
Not I times 2, but I'm going to do this whole thing times 2.
Oh, okay.
Right? Because if I'm talking about I would be doubling this value. I don't want to double this value. I want to double this value. And this value is the whole thing.
Okay.
And that's it. Okay? So that's that. And then let's go and show that other array now. I'm going to grab this piece, copy it. And let's throw a bunch of comments. Whoops. Alright, so I'm going to throw this piece here. Now I'm going to recycle this piece of code. Okay, I'm just going to change this to array 2, right? And hope for the best. Run it. And what do we have? Array 1, 0. Oops, I showed it in reverse. So let's do this. let me grab this one time. So I'll show them both next to each other. There you go. One more time. Okay, so I have array 20 is equal to 364, which is the last one, 182 times 2, right? Then I have array 1, that's 312, which is this number times 2. Then I have the third one, 189 times 2. So it looks like it's working. Okay? Make sense? Okay, let's do one little thing. Notice how there's like a little glitch, if you want to call it that. So see how in here it moves to the right, right? Notice because it goes from 1 digit here to 2 digits, and then the column kind of shifts, or this column here gets shifted to the right a little. Okay, so how can we make it so that it reserves 2 spaces for this here, for this digit?
You would reserve it in the C out, right?
Yes, in the C out. So what I'm going to do in here is I'm going to do, let's do the set W. I think it's set W, or I don't remember. Let's do this. Set W. I'm going to do 2 here. And I think I have to do include IO manip. IO manip. That's for the set W business. Now the set W is no longer red. I don't know if it's going to work like this, so let's run it one more time with just that. Oops. IO manip. What did I forget? Oh, I forgot to close it. Run it again. And yeah, there you go. So we fixed it. We fixed it for the array 2. All right. Array 1 still messed up because I didn't do that to the array 1. So let's go do that to the array 1. I'm going to do a set W in front of that. Right there. Okay. I'll run again. And now it's all lined up. Questions? So people had questions on that one, so there you go. Now you have it. What else we have? And again, all of the questions for this week, all of these 61 through 67 are in the video that I have for Monday, right? So I'll put a little comment here. So hints for all the assignments. This one here is hints for the below assignments. Okay, so that's that one. And yours today is going to be, I don't know, another one. 09. So tell me what else you want to add to your notes in your video. Anything you want. Going once, going twice, going 3 times, going 4 times. Anything you want.
Anybody have a question about 49?
Okay, there you go. 49. Let's look at the 49. Okay, Fibonacci. I actually did that also in that video, but I'll show it for you because you asked. All right. Okay, so here's the Fibonacci deal. And the Fibonacci, it's not as easy as it might seem. You know, I guess maybe. I sound convinced. Huh? Who's Fibonacci? He's my grandfather. All right. Yeah. I'm, you know, I contributed, my ancestors contributed to, no, I'm just making stuff up, okay? Don't take me to court for that. Who cares who Fibonacci is? Some Italian guy who worked on math, okay? I don't even know if he's Italian.
Okay.
You should know, Italian mathematician, notice Fibonacci of Pisa. He made many original contributions, complex calculations, algebra and geometry, and pioneered number theory and indeterminate analysis, discovering the Fibonacci series. Now you know. And that was like 1,000 years ago. And he came up with that stuff. How about that? All right. He was probably like your granddaughter, Miss Tagliati. Okay. All right. So let's see how we're gonna break the Fibonacci code with our brilliant program. And by the way, I did provide a hint right underneath there, but let's pretend it's not there at all. Okay, Rigo, just for you. let's go through it. Let's go through it as I would. Okay, so let's first of all let's look at the Fibonacci numbers. So Fibonacci numbers. Okay, so the numbers, they go like this. You have a 0, then you have a 1, then you have another 1, then you have a 2, then you have a 3, 3. Then, can you guess what's the next one? 5. What about the next one? 8. Then, is it 13? 5 plus 8? I don't know. And then what? See how far your arithmetic extends. 21. All right, one more. Give me the last one. Extra challenge. 20, 34. All right, 34. All right, you get an A in the class. You no longer have to do any assignments. Just kidding. Okay, so here's what we're gonna do. So what's the relationship that you were just kind of eyeballing? What can you say? What if any subsequent Fibonacci number is equal to what? So if I was to write another one, that's going to be equal to what? The sum of what?
34 plus 21.
The sum of the previous two numbers, right? Is equal to the sum of the previous two numbers. Okay? So why don't we do this? I'm going to go in there and I'm going to make a variable int first. What's the first one that you want to, so the first one I'm going to start at 0, right? Int second. What is the second equal to? 1. How about the third one? In terms of the first and the second. Third equals what? First plus what? Second. Right? Does that make sense? Okay, so now what I have to do is, if I really wanted to show you the first 3 Fibonacci numbers, right, I'll do first, right, comma, then second, comma, and then third, right? No comma. You don't want a comma. Okay? So first, second, third, that will show you these 3 first numbers, right? But I want to be able to show as many as I wanted to, right? Without having to do this manually. So I'm going to make a loop. So let's say, first of all, let me count these things. So how many I have in here? This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So here's what I want to do. I want to show the first 9 Fibonacci numbers. Right? And if I run this thing, by the way, let me zoom in on a little bit. So if I run this thing, maybe I should put a little label in there. Fibonacci numbers. Okay, run it again. There you go. I got the first 3 Fibonacci numbers are there. Okay? Alright, I gotta do the other ones too, right? So I showed you these first 3, now I gotta show the rest of them. Alright, so I'm gonna make a loop for int I is equal to 0, I is less than 9, I plus plus. But since I already showed 3 of them, I don't need to do this 9 times. how many times do I need to do it? 9 minus what?
3.
3. Yes. All right? Because I showed the first 3. Okay? And then I go in there and I say, all right, well, my first, and how does it work? Initially, you have, this is your first, this is your second, and this is your third, right? Then it goes, then this is your first, this is your second, then this is your third, and then it goes, this is your first, this is your second, this is your third, right? So they all get shifted one down, right? So if I wanted to shift my first one down, I'm going to make it equal to what?
To the previous.
To the next, to the second. So in other words, the first used to be here, right? But then it's equal to the second the next time I go, right? So first and second are equal the second time I go through it. Okay? And the second becomes equal to the third, right? Second becomes equal to the third. You agree, Rigo?
Yes.
Second equals Rigo? Just kidding. Second equals what? Third. Okay? And then what's third equal to?
Fourth.
Second plus first, right? First plus second. Right? And then I show you the second, third, C out, third, with a little space, and hopefully that will do the magic. Right? So am I going to get 34? Maybe. No, I didn't get to 34. I got to 21. Okay? Why don't I make this thing less than or equal to this? Maybe that'll do. Oh, wait. I need to do another extra little space in here. Alright? Yeah, maybe I shouldn't have put commas. There you go. No commas. So we can see them easier. There you go. 0, 1, 1, 3, 5, 18, 31, 24. All that good stuff. You convinced? Okay. Now, what you have to consider, though, is that, number one, this needs to be inside of a function. Right? So we need to put all this stuff inside of a function. And we need to make sure that if the user says, oh, I only want one Fibonacci, then you only show this one. If the user says, oh, I only want 2 Fibonacci, then you show these 2. Right? These 2. If I want 3 Fibonacci, I show these 3. And then if I want more than 3, or I want 4, I show up to this point, and etc., etc., etc. So how do we do that? Let's grab this whole thing. We're just going to cut it, if I can. All right, cut it. Let's throw it inside of a function. Int Fibonacci. All right, int numbers. All right, that's how many of these we're going to show. So we're going to throw this in there. Int Fibonacci, and I'm misspelling Fibonacci, but I really don't care. Numbers. All right, and then I'm going to throw this stuff in there. Okay, so if my numbers, I need to consider how I'm going to be showing this stuff. All right, so why don't I break this thing down into separate lines? So I'm going to do this one here, then I'm going to do another one here. Then I'm going to do another one here, right? So what I'm going to say is, basically, if this one is, so first one is basically, let me break them down into little pieces, right? So this is, if my numbers is greater than or equal to 1, I'm going to show you this one. Okay, then the other one is if my numbers is actually not greater than, less than or equal to 1. If my numbers is less than or equal to 2, I'm going to show you the second one. Okay, if my numbers is less than or equal to 3, then I'm going to show you the third number. Okay. And then if my numbers numbers are greater than 3, then I'm going to throw that stuff inside my if and hope for the best. Okay? Does that make sense? So if my numbers are less than or equal to 1, I'm only going to show the first one. Let's make it equal. If my numbers are equal to 1, I show the first one. If it's equal to 2, I show the third one. If it's equal to 3, no, I don't want that either. Because if it's equal to 1, it'll show this, but if it's equal to 2, it's not going to show the other one. So yeah, this one should be greater than or equal to 1. Greater than or equal to 2. Greater than or equal to 3. Okay? So if my numbers is equal to 1, I show this one. I'm not going to do this one because 1 is not greater than or equal to 2. I'm not going to do this, and I'm not going to do this one either. So this one should be, I guess, greater than or equal to 4. Okay? Does that make sense? You sure? I'm not convinced. Let's check. So Fibonacci, let's show one number. Okay? Hope for the best. Fibonacci number is 0. Okay, 0 is the first one. Let's check it with a 2. 0, 1. Okay, so far so good. Let's make it 3. 0, 1, 1. Okay, so far so good. Let's make it, what do we have up here? 9? Wait, that's 10 actually, right? Because we started 0. Make this equal to 10. And wow, I actually did it. That's the Fibonacci numbers. Okay, the whole thing. You got more than the Monday class. In the Monday class, I left it without all these extra ifs and stuff like that. Okay, I basically gave him this piece that I showed you in the main, and that was it. Okay. See, what else you got?
I'm hungry.
You're hungry. I know you're always hungry. If you come to the club meeting and there's pizza, then maybe we'll remedy that.
So where's the money going?
Which money? In my pocket. Money's going in my pocket. Safe. I take care of it.
Would it be easier if we just order a pizza
From the cafeteria? That's actually a good idea.
Mm-hmm.
Yeah.
So hey,
Just give me some slices.
we might have pizza on this.
Yeah, that's a good idea actually. I never thought about that.
You just walk up there.
I don't think about things. I just, I breathe, and inhale and exhale, and that's it.
Buy like 5 burgers and cut it into like 4 pieces.
That's it. Just put like a little stick in each of the square pieces and feed them.
There you go.
See if Tagliati can spot the fake meat.
Oh my god. You can see pieces of carrot in them.
I was just reading in some of the news sites that now they have like apparently fake meat that appears to be bleeding in your burger.
Oh.
I don't know. They also had like a genetically engineered kale that tastes like bacon.
What?
Yeah.
Does it have the same nutritional value as regular kale?
I mean, I think it's just a regular kale, but it tastes like bacon.
That's just wrong.
That's just awesome.
No, that's just wrong.
That's like the best of both worlds.
When you try to lose weight but you just love bacon too much.
That's right. You eat some kale, some bacon flavored kale and
Okay, but
yogurt.
how much would it be? Would it be like for the price of bacon, or would it still be like regular price of kale?
I'm pretty sure it's gonna be cheaper than bacon, maybe, because
I don't think so.
pigs don't photosynthesize.
Like everything else.
But like if it's modified,
I guess
I'm
Monsanto will
pretty sure
charge you
they
extra.
charge just for that.
Yeah, you might also get cancer and stuff from eating
Yeah,
it,
but they'd be like, hey, you want to lose some weight? You want
That's
to eat
right.
healthy?
That's right. You
get
save
some
you
bacon
save little
kale.
piggy.
Yeah.
Mm-hmm.
I was reading this one thing that was like, it was like questioning like vegetarians because it was, what if you had meat, but it wasn't like through killing the animal? It was like made in a lab.
What if the animal just died of natural causes? Would you eat it then?
No?
It's kind of like weird. Why did that?
You can't.
die?
What if it was like a cow that was
If it died in sleep,
free
then
ranged?
that's different.
A
That's
free
okay,
a
that's
cow.
how people got
Here-
mad cow disease.
No, check this out. It was a free range cow, humanely raised, and then it was just killed by lightning one day.
Killed by lightning.
Yeah, like tore hit it with the hammer
But
or
see,
something.
I don't have it in me to like skin and like do all that, prep it.
But I'm just saying, if it was that case, would you then eat some meat?
Depends on how many you were, huh?
I don't think I would.
No, I'm trying to get the vegan's perspective here.
Yeah, I don't think I would.
Still no?
I don't think so. No.
Oh, all right, fine,
Just 'cause I don't know.
fine.
It's my morality. It's at stake. It's not
You
about.
would eat the grass, but you wouldn't eat
But I
the
thought it
cow.
was just for
That's
this.
like saying, oh, I'm just gonna eat meat because it's already dead. It's right there.
No. The reason why you don't eat meat supposedly is because these cows are not humanely raised, and they're not humanely this and that, right? But what if it was just like a happy cow, and then all of a sudden it had a
Okay,
heart
well,
attack?
If I'm a happy cow, that means I bonded with the cow. Like I don't want to eat little Annie. That was my cow.
All right, fine.
How am I gonna eat? You know what I mean?
Well, it's either you or the worms, you know.
I mean, the worms can have little
All
Annie.
right, fine.
You eat
God
the worms?
rest her
You
soul.
eat the worms?
So, I don't think
That's
I
right.
would.
What about worms? Do vegans eat worms?
I don't know, dude. Honestly, I wouldn't.
How about crickets? How about like protein powder made out of
Okay,
crickets?
See, this is interesting because my sister and I have that different perspective. Cause she.
Sorry, whoever's watching this video. Sorry, guys. This is pretty much we're at the end of the lecture here, and now we have to educate you on veganism.
No, well, my sister, she thinks it's okay to eat fish,
That's pescatarian.
but she still says it's a vegetarian.
No, she's pescatarian. That's a different term.
No, well, that's what I say.
Not a vegetarian. Now you're a pescatarian if you eat only fish.
But,
And those people actually tend to have less heart attacks and stuff like that than the rest of us.
But she said that it's okay because like they don't have the nerves that like cause pain. Like.
I don't know about that.
Do you guys, is there any vegan beer?
Vegan
I don't know,
beer?
I've never looked into that.
Vegan tequila?
Liquor?
I mean, I guess if you make your own, 'cause, like that's what we did. We put
What
pineapple,
would you put in it though?
sugar, and just let it chill for like a month.
Well, there's no dairy products or anything in yeah. Anyway, any questions whatsoever, by the way, so I can stop this video? Because I'm sure the online students would love to hear more about vegan stuff, but sorry guys, you got to come to the actual class if you want to know more. So, all right, let me know if you have any questions. Email them to me, or send me smoke signals, or pigeons, and I don't know what else is there. Do you have
Post this up there, please.
I will, if you pay me enough, I will post it for you. I'm just kidding. It's for you.